Hey Algebra 1, welcome back to the video notes. This should be the last one. Starting you off with a question on 8.6. Take a look at this. If a to the third equals a to the x, then what does the x have to equal? So notice they have the same base. So let's see if you guys can figure that out. I know most of you got it. It's a lot simpler than it looks, or than you might think. It's really just 3. Because if this has the same base, that's a 3 there, then this would have to be a 3 over here. So I know a lot of you did get that. So we're going to use that. That's actually a property that says as long as the bases are the same, like we have a here, then the exponents have to be the same for an equation, for an equal sign. So how can we use this? So take a look at how we can use this to solve exponential equations. So we have 4 to the x minus 1 equals 1024. If I use my calculator, I'm going to rewrite 1024 as 4 to the 5th power. And I'll show you how to do that in a moment. So now you can see I have the same base. So those exponents must be equal. So it's basically the base cancels out. And I get x minus 1 equals 5. And then if I just add the 1 to both sides, I get x equals 6. And you can see that that works. So x minus 1 is 5, so we would still get 4 to the 5th over here. That's how we can solve for x when we have an exponent. So let's take a look at number 10. And now I'm going to show you how you'd use your calculator to figure out what this base would be. So take a look at this one. My base is 3 right now. So I want a base of 3 over here. So I'm just going to rewrite the left side, right? And I'm going to take my calculator, right? And I know that I want a base of 3. So like 3, I know it's not going to be 3 squared because 3 times 3 is just 9. So let's try 3 cubed, 3 to the third, and that's 27. So that's not 81, so let's try 3 to the 4th, and you can actually see this on the other side. So it is going to be 3 to the 4th. Now that I have the same base, basically what that means is these exponents have to be equal. So it's like my bases cancel out, and I'll just be left with 3x plus 1 equals 4. And that's what this property says. The exponents have to be equal, so I don't care what the base is anymore. I'm going to subtract 1 from both sides, just like we normally do to solve. Thank you, school, for making a bell right there. And then I'm going to get 3x equals 3, and if I divide both sides by 3, you're going to see x equals 1. And that is my final answer. So that's how you solve one of these. I'm going to show you 2 more examples pretty quickly. I'm going to ask you on one of them. I'm actually going to skip around. You know what? Let's do this one, number 12. Okay, so let's do number 12. I'm going to skip 11 for a second because 11 is tricky. So for number 12, all right, same thing. So I've got a base of 9. So I want to make a base of 9 on the other side. So I just don't know what the power is going to be yet. So right here, I've got 9. Okay, I'm going to raise it, square it. Well, we know it's not going to be squared. That's too small. Let's see. I'm going to do 9 to the 3rd power. Still too small. 9 to the 4th power. That's it. There we go. It's 9 to the 4th power. Okay, now that I have the same base, the bases cancel, and I'm left with 3x plus 3 equals 4. I'm going to solve by subtracting the 3 from both sides. And I get 3x equals, so 3x equals 1. Now I am going to get a fraction. That could happen. So I get x equals 1/3. Now see if that works. So if I plug that back in, 3 times 1/3 would be 1, and 1 plus 4 is 4, and that's the exponent I should have gotten. All right, let's go ahead and talk about number 11 because it is a little bit tricky. Right now my base is 4, and if we do 4, so if I do 4 raised squared, we know that's 16. 4 to the 3rd is 64. So it's too big. I want to get a 32, and those are both too big. So every once in a while, and I'm not going to do this too many times to you, every once in a while you need to change both bases. So we also know that 2 squared is also 4. So I'm going to change this to a 2. And then what I do is I'm going to put the 2 on the outside. So if you see, if I cover this up, 2 squared is the 4, and there's the x minus 3 that was originally there. This is going to be challenging for some of you, but some of you are totally ready for this. Right, now what I'm going to do is I'm going to do the 2. So we know it's not going to be 2 squared. It's not even going to be 2 cubed. So let's just jump into 2 to the 4th and see if that gives me 32. Not quite yet. 2 to the 5th. There we go. So that's my 32. So this side's going to be 2 to the 5th. So 2 to the 5th power is 32. Now I've got the same base, so I can cancel those out. And I get, I'm going to go ahead and distribute this. So 2 times x is 2x minus 6 equals 5. I'm going to add the 6 to both sides. Oh, this is going to be another fraction. Okay, and I get 2x equals 11, divide by 2, divide by 2, so x equals, you can just leave it 11 halves. If that just really bothers you, it's okay to put 5.5 also. Either one would be fine. Okay, I'd be fine if you left it as 11 halves. That's less work. Alright, so guys, that is how you solve these, and I will see you guys back in math class.